All right, I'm going to be doing problem 8, which is what is the angular momentum vector of the 2 kilogram 4 centimeter diameter rotating disc in figure 1? Give your answer using unit vectors. All right, and on the screen I do have the answer showing, so I'm gonna just work my way there. And then this is the figure, which is going to be really important. So when we go to solve this problem, we're looking for the angular momentum, or L, and we know that L, as you can see in my work here, is equal to the inertia times the angular velocity. So the first thing we need to do is identify our equation for inertia, because as you know, that's going to depend on the shape we're looking at. So in the figure we can see we're working with a disk, and the inertia equation for a disk is just the mass times the radius squared divided by 2. So I have that there. And then if we plug those numbers in, we know that the mass of the disk is 2 kilograms. And then we're told the diameter of the disk in centimeters. So we're told that it's 4 centimeters. So the radius is going to be 2 centimeters, or 0.02 meters. And then that's going to be squared divided by 2. And then we need to multiply that by the angular velocity, which we're told that it's 600 revolutions per minute. So you can see my little shorthand, I just have it as 2 pi over 60. If you see in the parentheses below that, that's just a quick way of moving from revolutions per minute to radians per second. It's just 2 pi radians per revolution times 1 minute per 60 seconds. And then I have that comes out at 0.025 kilograms meters squared per second. And that is the units of angular momentum, so we're good there. And then we are asked to do the unit vectors. So the first thing, the main piece of information we need to get is which direction the vector is going to be pointing. And we can get this from the graph. So we see that the disk is rotating clockwise on the x-axis, so around the x-axis. And if we use our right-hand rule, and we line up our fingers in the direction that it's pointing, you would get that it's pointing along the x-axis out of the screen towards us, and that is the negative x direction. So we know that if we split it into vectors, the x value is going to be negative. And then since it isn't pointing in the y or z direction, both of those values are just going to be 0. And you can see that I have that inputted here. We got our value as 0.025 for x, and we noted that that's in the negative direction. And then for the y and z vectors, that's just going to be 0. So that's what we did there. This problem is important because it's helpful for identifying the different equations for inertia for different shapes. So just being able to identify what you're working with. And then keeping track of your units is always helpful to make sure you're getting the right answer, or you're doing it the right way. It's always just a good double check. And then being able to identify the direction of the angular momentum vector from the right-hand rule, just practicing that. So yeah.